Hello Senior 2, how are you all? Today I'll talk about the interference and diffraction. The interference. To study the interference of light, we carry out the following experiment. Thomas Young's double-slit experiment. Objectives. Number 1. Proving the wave nature of light. Number 2. Investigating the phenomena of light interference. Number 3. Determining the wavelength of monochromatic or single wavelength light. Our experiment consists of a source of monochromatic light that has wavelength one constant value, barrier A and barrier B. Barrier A has only one slit. Barrier B have two slits, S1 and S2. Screen C to receive the interference pattern. Steps. When turning on the light source, the light waves pass from slit S in form of waves or cylindrical waves. When light waves reach two slits, thus two slits S1 and S2, the two slits are interference and they produce two coherent waves have the same frequency, amplitude and phase. The two waves, when interfere with each other, gives bright fringes or dark fringes. Because when the crest of the one wave mating with the crest of another wave, making reinforcement and the intensity of the light increases. When the crest of the one wave meeting the trough of the another wave, they weakness the intensity or decreasing the value of the intensity. To calculate the distance between two fringes, light or dark, delta y equals lambda times r over d. Delta y, the distance between two fringes. Lambda, the wavelength of the used light. R, the distance between the double slit barrier and the observation screen. D is the distance between the two slits. The conditions of interference. Number 1. Each of the two light sources must be monochromatic. Number 2. The two light sources must be coherent, have same amplitude, frequency, and phase. We have two types of interference: constructive interference and destructive interference. Constructive interference, when the crest of the first wave meeting the crest of the another wave, they all have reinforcement of the amplitude and frequency and the intensity. And its rule of delta y equal m times wavelength. Yeah. The destructive interference, when the crest of the first wave meeting the top of the another waves, they weakness each other, and delta equal m times m plus half times wavelength, and the m equal 0, 1, 2, 3, and so on. Example number 1. In the double slit experiment, if the distance between two slits was 0.15, so D equals 0.15 millimeter times 10 to the power negative 3, and the distance between the double slits barrier and the observation screen was 75 centimeter, so R equals 75 times 10 to the power negative 2, and the distance between two successive bright fringes was 0.3 centimeter. So delta y equal 0.3 times 10 to the power negative 2. Calculate the wavelength of the used monochromatic. From the rule delta y equal lambda r over d, we have all of them except the wavelength. So the wavelength equal delta y times d over r. The light diffraction. The conditions of clear appearance of light diffraction, the wavelength of the light wave is comparable to the dimensions of the barrier size. A lot bigger than the wavelength of light, the diffraction doesn't appear. comparable to the wavelength of light, the diffraction appearing and becomes more clearer by the decreasing of the aperture size. What's the difference between the refraction, and diffraction? Reflection is the change in the direction of wave, and the properties, the law of reflection states that the angle of incidence equals the angle of reflection. Examples: mirrors, mirror sign in an ambulance. Refraction, the change in the direction of waves when they travel across a boundary. The properties occurs in all forms of waves like light, sound. When the light wave travels from air into glass, the angle of refraction is smaller than the angle of incidence. Examples: swimming pool and water wave with white light. Diffraction, the spreading out of waves when they pass through a gap or around the edges of the obstacle. The properties, the narrow R of a gap is the greater the diffraction, the wider gap is the greater the diffraction.